Welcome to the podcast series Africast. Allow us to introduce ourselves. We are Jaimee,
Marius,
and Patrick.
And we are students of the Technical University of Munich with different study backgrounds. Africa is an emerging continent. In particular, Ghana is one of the fastest growing economies worldwide. We would like to raise awareness for the academic environment in Ghana. But why do we focus only on Ghana? Last year, the Technical University of Munich established a scientific collaboration with different universities in Ghana. We have the impression that there's a lot of potential for more people to learn about this. So we hope that this podcast sparks your personal interest and that you share it with your friends and family if you liked it. And now, enjoy. We are happy to welcome Johannes Winklmaier today as our guest. He studied mechanical engineering and is an engineering PhD candidate and lecturer at the Technical University of Munich. We invited him because he is an expert when it comes to the potential of renewable energies in less developed parts of the world. Hello, Johannes. Thank you very much for joining us today. In your dissertation, you write about energy-related development concepts for rural communities. Based on the subject, you gave a very successful lecture at TUM, which is planned to be repeated this year. And beyond that, you are the founder of TUM Africa, the NGO where students of TUM can participate and develop sustainable solutions for African villages. Your dissertation is based on the assumption that energy has an effect on the economy and on the population. Could you tell us a little bit about how electricity is related to economic growth as well as population growth? What is your idea behind that or your theory?
Very much hello from my side as well. So you can see a clear correlation between access to reliable and affordable electricity and economic growth, or in a bigger picture, the Human Development Index. So the countries with a lot of energy consumption and access to this cheap electricity are very highly ranked with the Human Development Index. The less developed countries go with little, not sufficient access to electricity, and you see them on the bottom line of the Human Development Index. In a practical example, you can say that you need access to electricity to add value to any kind of production so that you enable yourself to grow economically.
Okay, and what has it to do with the population growth? Because population growth is one of the acute challenges of today and tomorrow.
You can see by statistics that in the past, the regions, countries that enabled or improved the access to electricity, this led to an improvement of economic productivity, and then the birth rate significantly went down. Especially you can see this the last decades in the Arabic countries, a few sub-Saharan countries starting this process as well. A practical example or two major reasons are the economic security. The moment I know that I have economic security for months or even years, I don't invest as much as I've done the last centuries in certain cultures in creation of children, that they are the security for my own age.
Don't have to be the insurance for yourself.
Exactly.
Okay.
And the other part is when you just think about the health sector, the moment you have also in remote areas stable access to electricity, this is crucial for hospitals. So when a hospital has access to electricity, it can provide much better security, protection, healthcare for the local people. So the mortality rate of especially young babies, children is going down.
It's going down. I see. So power access is related to economic development and population growth, but which energy source is particularly suitable for your concept? Are we talking about nuclear power, fossil fuels, or renewable energies?
We talk very much about renewable energies. Of course, there is an environmental drive behind, but we started more from a socio-economic point of view out. These remote villages have the two problems why they don't have access to electricity. The one point is they are so remote that it's really very costly to connect them to a national power grid. And even if it would be economic feasible, often the government is failing in infrastructure development with different reasons. This can be bad governments or just that the government itself doesn't have enough access to money. So this doesn't work. In the past, this always was tackled with diesel generators, so that villages far away from economic centers have no power line. So the people or the richest people in this community tried to get partly power access with diesel generators. Besides the environmental damage that is done with this is very, very costly. Mm-hmm. Power from diesel generators is the most costly version you can have.
True, and renewable energies are cheaper and sustainable. So.
Exactly. And the development over the last years, where wind, but especially solar power, got cheaper and cheaper, and this development will continue, enable them to be price market competitive. So, and then solar power has the very strong advantage that it's modular, meaning that when I buy one module, I have this almost the same economic feasibility than when I would do a very big plant with 1 million modules.
Okay.
With coal, it's very different. Coal is not
your concept of decentralized.
Exactly.
It's a decentralized concept.
Totally.
You can install and expand it based on small cells and modules, right?
Exactly.
Okay.
It's also very fortunate that it can be stepwise built up. So when you build one big power plant, you have to build the whole power plant at once.
Sure.
When you electrify a village somewhere in sub-Saharan Africa, you can start small, and in 1-2 years you add another solar PV panels and batteries, and a few years later, so on, depending on the economic growth and the wish of the people there.
Okay, you just mentioned that solar energy is less expensive. Can you estimate the costs to electrify an African village?
There are very much variables in this calculation and figure, but you can say per capita you have 200, 250 up to $300 investment costs.
Okay, and how are the costs distributed over time? Are there like initial costs for the investments and later also steady costs?
There is a high share of investment costs. Of course, in real life, especially in the northern hemisphere, this wouldn't be paid at once, but you depreciate it, so you pay it off year by year. But this investment cost is a high bulk, and then you have rather low operational costs. For our systems, this would be a technician, this would be spare parts. You have to take into account that the batteries, which we try to avoid because they are very expensive. So in these kind of solar-powered systems, you need a few batteries, but we want to keep the amount as low as possible because they are very expensive and they have to be replaced every 3 to 5 years. Solar power or water pumps have a lifetime of 20 to 30 years, much longer.
Okay, but I guess you still have to find some investors to give you a credit, right? Is this easy in Africa, or how do you work with this?
This is very, very strong. There's a little economic science in it. It's easy to get investors for projects up to $50,000. It's easy to get investors for projects more than 5 or 50 million, but this section, this middle size investments from 5,000 to 550 million, it's hard to get investors. And actually this is both the drive for our research and the work of our NGO, that we create proof of concepts on paper by science and by implementation through the NGO to show, yes, these kind of investments in our so-called decentralized energy, water, food systems are a safe investment. And we are already talking with corporations. In German, they're called Genossenschaften, which had been a big driver for the energy transition here in Germany. They invested a lot in wind power. And in Europe, these kind of investments are quite tough right now. So they are very interested in these social investments in Africa. And we hope that in a few years, we can really have real investors for such a project.
Okay, so your NGO serves to guarantee some security to those investors. And of course, your successful examples of the past, for example, Zimbabwe or other countries, are helping you with this. But once you got the capital, what exactly is the credit used for? So what do you invest in?
So it's mainly buying photovoltaic modules, a few batteries, then water pumps and water tanks. So this was not mentioned before. Our big aim is to create any security for investor. Or our first idea is to get energy access for the population. Therefore, the by far best option is solar power, which has high investment costs. So we need some financing. For the financing, you need investors. The investors need security. Right now, they don't have the security because a solar panel mainly would be used for lighting, for cooking, for a fridge, which is very important for the living quality of the people there. But
not profitable.
It's not profitable, so it's no security for any kind of investor.
Yeah.
So that's why we looked into so-called productive loads. And in Africa, agriculture is so big. So 80%, we kind of can say, of the African population is directly, indirectly involved in agriculture production. So, but this is a so not lifted potential because there haven't been established structures because of the lack of electricity. Right now, most of the farmers, especially the small-scale farmers we are talking about, they totally rely on rainfall. If there is a long dry season, their plants die, they have big economic problems.
Okay.
If there was little rain, they have low productivity and can't invest in better seeds or fertilizer for the next year. With our systems, we want to use the solar power very cheaply for water pumping so that besides private water consumption, we can provide a lot of water sustainable. We have a lot of measurements and models that we don't take away too much water from the groundwater.
Okay. But you store the water somehow.
Exactly. We pump it and then we store it in a lot of tanks. And the moment it's needed for agriculture or private consumption, you can use it.
Okay. But I have one question. Solar energy is only provided when the sun shines. So is there also, besides the batteries, a possibility to store the solar energy? Because the batteries are quite expensive.
Very good question. So right now, the most innovative systems would be, as you described, solar power plus battery plus diesel generator. Because the diesel generator is opposite to solar power, a control-able. I can turn it on and off without any losses. But, as I mentioned before, diesel is not environmental friendly and very expensive. And with our systems, we substitute this diesel with a biogas motor. Because of our better access to water, we can improve significantly the agricultural production in our community. So the people not just make much more sales on a regional market for their maize plants, cabbage, tomato, but they also have much more biomass waste, which right now would be just put on the field, burned, so the nutrients keep on the ground. But
to fertilize the soil.
Exactly.
Okay.
But you would kick away all the energy content in these green leaves.
Okay.
There are carbon hydroxides, there's energy in it.
Organic waste.
Exactly.
So, okay.
So that's why you should put this together with livestock manure into a biogas digester. And the two outputs is biogas, which is a mixture of methane and carbon dioxide. And you have also a digestate, which is a highly concentrated organic fertilizer. So this digestate can be put back on the fields to keep the nutrients in the fields. And the biogas can be put into tanks. And the moment we need electricity, when there's not enough solar power, so when there are clouds or especially in the night, we just open the biogas tank, start our biogas motor, and have very cheap electricity even in the times without solar power.
This sounds like an approach that considers all different aspects. So my next question concerns your NGO, To Empower Africa, which brings your theoretical approach to reality. I think one could say that. How do you identify the optimal design for this decentralized energy, water, food system for one rural village? Do you question the people there? Do you travel to Africa? Could you explain it a little bit?
Very much. So we have kind of offer 9 services, and 5 are directly connected to this decentralized energy, water, food systems. And sometimes there's linkages to student projects, master thesis, and so on. So something is done, find out by student project, and some is totally independent by our NGO. So in the beginning, we do always a so-called site potential assessment, which has 3 dimensions. The one is remote sensing. So we try to get by the internet, by databases, data like irradiation, rainfall, soil quality of a certain location.
Like all the conditions.
Exactly.
You have on site.
Everything that is very much connected to resources. Then we go there to do last measurements for all resource assessment we couldn't do remotely, like special groundwater tests.
Okay.
And additional, the third part is on-ground surveys, which is everything which is connected to the human. Yeah, what is the consumption of electricity, water, and food of the population in a certain community? What do they like to grow in agriculture? What problems are they facing in these certain processes? And then we have enough knowledge about this community that we can. These are the input data for a model that we developed in a scientific way, with very interdisciplinary, where you put in all this data, and as output, you as either an investor or as a community member in rural Africa get the number. Okay, I have so much money, and for my community it would be the best to buy so many solar panels, so many batteries, water pumps, water tanks, the biogas system, how much agriculture I should do, which kind of crops would be the best based on the soil, water availability, market prices. And how much does this cost as an investment? And for running costs, the running costs are very much dominated by salaries for technicians and farmers and fertilizer.
So you basically get your personal design for this decentralized system. Okay. How many students are part of the NGO, and what does your work look like? Can they write like a thesis based on projects? Yeah.
So far, we are a very young NGO, less than 1 year old. So we are right now taking the next step from after the first year. So most of our volunteers, we have 25 very active volunteers right now, but a way bigger circle, which is just particularly supporting us. But this 20-25 students mainly had been part of student projects before or did a master thesis in that field, and afterwards somehow want to contribute by practical work. Mm-hmm. So for example, there was recently a master student who did a thesis about the perfect design of such a energy water microgrid, and afterwards he went for 1 month to Zimbabwe to install parts of it as a volunteer.
Okay. Are you looking for more students to join your initiative? And are there certain requirements concerning your personal profile, interests, or scientific background to participate?
Totally. So there are 2 very different fields we are looking for volunteers. The one is really the groundwork. Okay. Where we need good engineers, people who know about agriculture, people know about socioeconomic structure. So how would be the perfect...
but it's very interdisciplinary,
very
right?
much, very much. So this is the groundwork. And then there's the work here back in Munich, where it's about social media, fundraising campaigns, marketing, articles, things like that.
Okay. Last but not least, I would like to ask you, Did your personal contribution and involvement with this project had an effect on your life, and how did it maybe change your personal perspective on things?
Very much. Good question. I'm surprised. I'm so motivated to bring a lot of smart students. I'm enjoying a lot working with them to bring these smart students, perhaps offer them a different option than the common industry jobs doing this. And the last year, I was always very happy when a student that worked with me got a job in Africa Renewable Energy startup, or the GIZ, which is doing great projects in developing countries, things like that.
Okay, nice. Thank you.